Hello everyone, welcome to Mifratech. Today in this section we'll see important machine learning, that is deep learning library Tensorflow. So these are the concepts we are going to cover in this section. First we'll see what is Tensorflow and what are the features of Tensorflow. Next we'll see different operations can be performed using Tensorflow and what are the advantages and limitations of Tensorflow, and at last we'll see the applications of Tensorflow. So let's start our discussion with what is a TensorFlow. So as you can see here, the TensorFlow we can provide a different a different platform for us to training, both in the training period and also in deployment. So let's start our discussion with what is TensorFlow. TensorFlow is an end-to-end open source platform for machine learning. As I told, it is an open source platform for doing any machine learning operations related to deep learning and neural networks. So it has a comprehensive and both flexible ecosystem of tools, libraries and community resources. TensorFlow make use of Keras for doing operations on deep learning and neural network related problems. So it helps developers to easily build and deploy model powered applications. As I told, it mainly helps us to both build and deploy machine learning applications using this TensorFlow, and it is a symbolic math library based on data flow and differential programming. So TensorFlow is a machine learning framework which is mainly developed by Google Brain team. So a tensor, as I told in the TensorFlow term, a tensor is nothing but a vector or a matrix of n dimensions which represent a type of a data. That is what a tensor means. In TensorFlow, a tensor is the collection of a feature vector of n dimension. So the flow of this tensor only is TensorFlow. For instance, if you have taken 2x3 matrix with 1 to 6 values, usually we'll write this matrix as like this, but TensorFlow will represent that 1 to 6 matrix like this only as a tensor vector. So if we create any 3-dimensional matrix with values 28, so TensorFlow will create these as a like this. So what are the different features of TensorFlow? So as I told, it mainly helps in easy model building, and it is based on graph computations. So we are going to get different graphs in this using this TensorFlow platform. So it efficiently works with both mathematical expression involving multi-dimensional arrays, and it supports deep neural networks, machine learning concept also. It supports both machine learning and deep neural network concepts also, and it is mainly it supports both GPU and CPU computing also. High scalability of computation across machines, it can handle a huge number of data set and it gives with a reliable output. So responsive, so these are the different features. Responsive content, it is very flexible, it is easily trainable, so we can easily train the model using this tensor platform, and we can also use for parallel neural network training for a larger data sets. As I told, it is a open source, and we can extract feature columns, and also we'll do some mathematical statistical distributions. So let's see what are the different operations can be performed using TensorFlow. So we'll see how to create a tensor of n dimension. To do that, first we'll see to create a tensor of 0 dimension. For that, first we have to import tensor. After importing, have to give a default name. You can give tf dot constant of 1 tf dot int. So this is the data type have to give as a input. If you print r1, we are going to get a tensor of 0 dimension. You can also provide name for that. To do that, have to use tf dot constant of 1 a data type. We can give name as myscalar. So if I print, we are going to get myscalar tensor. So we can create a tensor with decimal values or with a string. So to do that, we have to use just tf dot constant of, have to give the what is the decimal value we want to give that for tensor, and we have to mention the data type, that is tf dot float 32. So the 32-bit float value we are going as a decimal. If we print q1 underscore decimal, we are going to get a tensor with a decimal value, or we can also use string data. For the tf dot constant of, we are using TensorFlow as a string, tf dot string. So if we print, we are going to get output as a string string tensor. So also we can create a one-dimensional tensor. To do that, we have to give tf dot constant of, we have to mention a vector values, we have to mention the data type. So if we print, we are going to get one dimensional tensor. So we can also store a boolean value inside a tensor. For that we have to just use tf.constant. Boolean value is true false only. So tf.bool is a data type we have to mention in as a parameter. So we can create an array of two dimensional, and two-dimensional array can be created using this TensorFlow. So similarly we have to use tf.constant of, we have to mention the two dimension and we have to mention the data type. So while finally if we print, we are going to get a two-dimensional array. So we can also similarly create a three-dimensional. For that we have to give three-dimension input inside the parameter as for the tf.constant, and we have to mention a data type. Similarly we can check a shape of a tensor, like we can check the what is the shape of the tensor. To do that we have to use, first we will like tf.constant of, we will give input parameter as a tensor value, like a matrix value. To see the shape we have to just use m_shape is shape. If I print, I am going to get the shape of the tensor, like you can, is a you can see this is a three-dimensional tensor. So to create a vector or a matrix which is filled with 0 or 1, so we can create a vector or like a tensor which is filled with 0 or 1 also. Let's first see how to create a vector of 0. To do that, the inbuilt function tf.zeros of 10, if I mention, I am going to get a tensor of 10 zeros. So we can also create a vector of 1s. So if I just give print tf.ones of, so it is given to give like a like you can create a 10 rows and 10 columns of 1s. So we can also create a tensor with 3 rows filled with 1 and zeros. So to do that, just to print out tf.ones, the inbuilt function we have to use, and we can mention the shape. So we can do, usually also we can create like filled with zeros also. So we can create a matrix with 3 cross 2 with 1. So for that we have to use just print of tf.ones. Inside that we have to mention the shape of the tensor or a matrix. So we can also convert a like a data type, like you can convert a float tensor into integer or integer into float, like that also we can do. So let's see how to do that. For that first we have to take a data set as a float data set. To convert into integer type of data set, we have to use tf.cast. So tf.cast function is going to convert. Inside have to mention what data, like the source, which type of data type we have already, for which we have to convert, that we have to mention as a second parameter. After that we can print, if we will going to get the output as a float tensor is converted into integer tensor. So we can also find a square. Like to do that we have to mention this tf.constant of 2.0. So for this, to find out the square of this data, we have to use tf.square root of s, sqrt of x. So this is going to give us the square of a matrix. So there are a lot of operations we can perform using this TensorFlow. So these are the operations. So we can use df.exp of a, this is going to give the exponential. We can use square root also. We can add two tensors. We can subtract using tf.subtract. We can multiply two tensor using tf.multiply. Using tf.divide, we can perform division between two tensors. We can perform power. We can find out the power of a tensor. So these are the different inbuilt functions we can use to perform a different operation. So first we'll see one example like this example. You can use all these functions also. First we'll see how to add two sensor. For that first we have to create two sensor. So using tf.constant of a one-dimensional like integer tensor we created. Similarly one more integer. So these two sensors, to add we have to use an inbuilt command, that is tf.add. We have to give two tensors as a like input parameter. After that, just if we print, we are going to get output as a these two sensors will be added up a value. So section, what is session? A session will execute the operations to the graph. As I told, it like a TensorFlow makes a computation in a graphical way. So a session will execute this operation to the graph. Like to communicate the graph to the values of a sensor, we need to open a section. So inside a session we must run as an operator to create an output. So let's see how to open a session and how to interact with it. First we have to create two sensors, x and y. First we will use x tf.constant of, then tf.constant of. After creating two tensors, we'll create the operator by multiplying. So we used multiply operator, that is tf.multiply of, we operated between x and y. And after that we have to open a session all the computation will happen in this section only, as I told. So to create or open a session, we have to use tf.session command. After that, here we are giving what is the operation we as the input. So after printing the result, we can close the session using .close command. So steps of creating a TensorFlow pipeline. So we can also create a pipeline in TensorFlow. For let's see how to do that. First we have to create the data, like import numpy as np. So here we created a random number of using np.random sample. We have created we taken a random input data. Then we have to create a placeholder. So using a placeholder, like to create a placeholder, we have to use the command tf.placeholder. So for that we are taking like a tf.float as the parameter. We have to mention the shape and the name also we can give. So after that we have to define the dataset. To define a dataset, has to use tf.data dataset.from tensor_slice. So this command is going to use to define a dataset. After defining a dataset, to create a pipeline, we have to use what is that iterator is equal to dataset.make_initializer iterator. So these two commands we are going to use to create a pipeline. So let's execute this operation. So inside a session .run, we are using to use the iterator to execute this like pipeline operation. So those are the different operations we can perform using TensorFlow. Still there are a lot neural network related operations we can do. So what are the advantages and limitations of TensorFlow? As I told, it is an open source platform and it makes helps in data visualization. It is Keras friendly because Keras is built on the top of TensorFlow only, so it makes use of Keras in the deep learning operations. So it is scalable and it gives the parallelism, and it is compatible. So it both graphical and architectural supportable, like you can call library. So what are the good stuff? As I told, it provides graph, a library, good library management. It helps in debugging, scalability and pipelining. So these are the different, like you can call features or advantages of the using TensorFlow. So what are these limitations? As I told, it needs frequent updates, and it is some cases it is inconsistent. So architectural limitations will be there. It needs some dependencies we have to learn or we have to import before like performing any operation using this TensorFlow. And some cases it will be slow speed. As I told, these are the disadvantages, or you can call a dark side of TensorFlow, as there is no support for Windows, like missing symbolic loops. There will be computation tests, benchmark tests. So these are the things you have to do in TensorFlow. So these are like some limitations. Like as I told, no GPU support other than NVIDIA, only language support. So these are only GPU support is NVIDIA inside TensorFlow. So what are the applications of TensorFlow? As I told, we can use these TensorFlows to solve machine learning and deep learning related tasks, and in real time Google uses this TensorFlow, as I told, to upgrade their services it provides, such as Gmail, Google search engine, image captioning. So all of those like Google, what are the applications we get to update those or to related operations to those as Google makes use of this TensorFlow. So we can also do image recognition, voice recognition, or video detection. So in these applications we will make use of TensorFlow. Like a text-based application also we can do, like classification and regression applications. So we can also TensorFlow will be used in self-driving car systems, in automation, in many more automotive machines also it is used. So as I told, image recognition, voice recognition, video detection, a text-based application. So these are the different applications where you can use a TensorFlows. So we like see, you can see this face detection, all those things will be done using TensorFlow also in a virtual assistant, like example like Google Assistant, a series. So in those applications also you can make use of TensorFlow in a self-driving cars also. Thank you.